In this video, we're going to look at the Pythagorean theorem of statistics in a little more detail. If you're a visual learner or if you're a person who likes geometry, this will be right up your alley. Pythagorean theorem of statistics says that if random variables x and y are independent, then the variance of x plus y or x minus y is equal to the sum of the variances of x and y. We can apply that to any situation where we have a linear combination of two random variables. So for instance, if we have x plus y and the standard deviation of x is 5, the standard deviation of y is 8, we can put those into a little right triangle here. We'll have the 5 here and the 8 here, and we'll apply the Pythagorean theorem. This hypotenuse is going to be the square root of 5 squared plus 8 squared, and that would be the square root of 89, which is approximately 9.43. So it's pretty simple to do, and this would apply if we had x minus y as well. If you have your x's and y's multiplied by some coefficient, that's okay. You can just take 2 times the standard deviation of x, which would be 10, and the standard deviation of y, which would be 8. And then you find your Pythagorean theorem here. Take 10 squared plus 8 squared. This will give you the square root of 164, which is approximately 12.81. If you want to find the standard deviation of this linear combination, x plus 1.2y, well, we can keep the standard deviation of x the way it is. We'll multiply the standard deviation of y by 1.2. That'll give us 9.6. And then we'll take the square root of 5 squared plus 9.6 squared, and that is going to be equal to the square root of 117.16, which is approximately 10.82. If you look at 3x minus 2y, well, you can multiply the standard deviation of x by 3. That'll give you 15. And multiply the standard deviation of y by 2. That'll give you 16. And then the hypotenuse of this triangle is the square root of 15 squared plus 16 squared, and that is the square root of 481. Which is approximately 21.93. So you can use this idea, the analogy between this rule for variances and the Pythagorean theorem, to make your life a little bit easier when you're trying to calculate the standard deviations and variances of linear combinations of random variables. Here are a few you can try on your own. We have 0.6x plus 0.2y. We have 1.4x minus 2.5y, 4x plus 0.5y, and 2.6x minus 0.75y. You can pause your video and give those a shot, and then come back in a minute and see how you did. Okay, welcome back. The standard deviation of 0.6x plus 0.2y we get by multiplying the standard deviation of x by 0.6, gives us 3. 0.2 times the standard deviation of y is 1.6, and the square root of 3 squared plus 1.6 squared is 3.4, and that's the standard deviation of this linear combination right here. If you have 1.4x minus 2.5y, multiply the standard deviation of x by 1.4, you'll get 7. And multiply the standard deviation of y by 2.5, you get 20. And then the square root of 7 squared plus 20 squared equals the square root of 449, which is about 21.19. And that's the standard deviation of this expression. If you have 4x plus 5y, multiply the standard deviation of x by 4, you'll get 20. Multiply the standard deviation of y by 0.5, you get 4. And the square root of 20 squared plus 4 squared is the square root of 416, which is about 20.40. And then finally, 2.6x minus 7.75y just multiply 2.6 times the standard deviation of x, you get 13. 0.75 times the standard deviation of y is 6. The standard deviation of this expression is the square root of 13 squared plus 6 squared, which is the square root of 205, or about 14.32. So whenever you're working with a linear combination of a couple random variables, you can put their standard deviations or some factor times their standard deviations on these legs of the right triangle, and the hypotenuse of the right triangle will be the standard deviation that you're looking for.